MattStine, and for much of the last 2 years I've delivered a two-part series on the tour entitled Effective Java Reloaded. For all practical purposes, it's just an a la carte style rehash of the book Effective Java written by Josh Block. Now, one of my favorite parts of the discussion is when we get to item number 15, which tells us to minimize mutability. You turn that inside out, what we're actually trying to say is that we want to maximize immutability. Well, when we do this, we reap many benefits, such as code that is easier to reason about and that is inherently thread safe. Now, this can carry us a long way in the direction of program correctness and decreased complexity. However, when we start to program with immutability, a couple of major questions come up. The first one is the necessity for using a separate object for each distinct value, meaning that we never reuse or mutate an object that we already have. Now, this can quickly cause us to have performance concerns. These concerns are amplified when we start to talk about large collections like lists and maps. Now, these problems are largely solved by what we call persistent data structures. Persistent data structures being collections from which we create new values, not by copying the entire data structure and applying our changes, but by creating a new structure that contains our changes, but also points at the previous structure for those elements which we haven't changed. And this allows us to work with data structures in a very performant way with respect to time and resource consumption. So we're going to look at persistent data structures and their associated algorithms, and then walk through some implementations on the JVM, such as those found in the functional Java library as well as in the Clojure language. Second, we run into problems when we start to use frameworks that expect us to program in a mutable style. A prime example of that is the popular ORM tool Hibernate, which expects our persistent classes to follow the well-worn Java Bean convention, including things like no argument constructors and getters and setters for every property. Well, a class like that can never be immutable. So how do we program with frameworks that expect us to program with immutability and yet still minimize mutability? Well, the key's found in not letting frameworks dictate the way that you design your code. Just because the framework requires something, don't let it force you to make the wrong decision. Use the framework as a tool to write your code. Don't let your code be a tool of the framework. And we'll examine strategies for doing exactly that.